Hi, everybody. Uh, Today we are going to introduce our project. Our topic is risk analysis and default prediction for Taiwan companies. And I am Pei-Ling, and my partner is Yuanxi Lai. The following list is our outline today. Today, we are going to introduce the background of our topic and the data set we are going to use, the model we use to train the data, and the final results. The background. Nowadays, the world becomes more complicated than before. Many companies that perform well may still default on their commitments to pay the money back. Instead of using traditional way, for example, some financial ratios like the Z-score, we today want to use some machine learning techniques to do the default prediction. In this project, we use the Taiwanese companies as a case study. The reason is we can find the financial statements on the market observation post system in Taiwan. And we are also familiar with the social media too. So based on these two reasons, we want to use Taiwanese companies as our data set. Here comes the data set. In the data set, we separate this into three categories. The first one is the financial statements. It's the most traditional way to get the credit score of a company. And then we use the social media and news. Since we think the public opinions is also important for us to know how good the company performs and how do investors think about this company. So during the search, we categorize the posts into four categories. The first one is company names, of course, because we need to know how many people discuss this company and how do they think about a company. And then the products and industry. This is also important because we need to know what's the demand of this product. For example, the memory. If the memory sells really good, then we can reasonably think that the laptop also sells good because every laptop needs a memory. And then the last one is the CEO's name. The reason that we want to search for the CEO is because sometimes the reputation of the CEO also affects the company. Because for example, some CEO is really competent, and if he get retired recently, then investors may lose some confidence to this company. Okay, and the last one is the company relationships in the industry. The reason that we want to take the relationship into account is because for some companies, it's not well known enough. So it's hard for us to find posts or news that discuss about the company. So we want to use the relationship like the upstream, the downstream, the competitor to know how good the company can be in this industry. So based on these three items, these are our data set. Okay, now I'm going to introduce more about our data set. As I mentioned before, our financial statements come from the market observation post systems in Taiwan. And then after we got so many financial statements, we can find many numbers inside the financial statements. So how do we choose the number that is useful for us? So we look into four categories. The first one is the firm size, and then the leverage, and the profitability, and the interest coverage and liquidity. The reason that we focus on these four categories is because these four are all related to how good the company can pay the money back. So based on this in mind, we take some ratios from these 4 categories and use them to compose our weight vector in the training procedure. So after getting these 9 ratios, okay, there are 9 ratios, and we can see we use the dictionary format to save the 9 ratios with the company name in our JSON files. So that's it. And okay, now next to the table. The table shows the 9 ratios. What are them? So basically, each variable are corresponding to a ratio. For example, the Z1 is represent the total asset value, and the direction shows is it means if the number becomes more and more, then it's good. It's a good sign to the company. And like for Z5, the long-term debts divided by the total invested capital. The number should be, if the number decreases, it means it's a good sign because it means that the proportion of the debt decrease. So it's a good sign for a company. So in this table, we can find some ratios we use. Next is the news and social media. For the social media, first, we want to use Twitter because we know many people use Twitter and have posts on it. However, we found that since we are not a premium member, so we need to use, so if we want to crawl over 7 days of posts, we need to pay money. So my partner and I decided not to use this. So we changed to use the PTT. PTT is one of the largest social media in Taiwan. Most of the people in Taiwan will use this platform. And we cross specific category for public opinions toward companies and industry. And then here comes the news. This part is simple. We simply use the Google search engine and we press the button of the news. And then we can find many news posts in our search engine. But for this part, we need to notice that since if we search a keyword that is from many, like for example, is we want to search the post during 2019 May to 2019 July, since it's already far away from us, so the search post may not have many results, and sometimes the Google search engine will use some other things like the wiki page or other Google page to fill in the search engine. So in this part, we also add a filter to filter some specific web pages because we know if the posts are come from those pages, for example, the wiki page, they're not definitely not a news. So we use the filter to quick filter out many useless posts. And the last thing is the platform we use. We use Google Cloud Platform since there are lots of keywords. So we need to use Google Cloud Platform and their processors to help us to crawl the posts quickly. Another thing that needs to be noticed is that we save this data separately into JSON files, and each JSON file saved by quarter. So for example, there are 4 quarters in 2019. So we can use the postfix of the file to know which quarter it is. Okay, now here comes the relationships of the companies. To count the relationship, we use a tool called RD. This tool can help us to build the graph database. And this database can show us the relationship between companies. We can get a concrete number which represents the distance between companies in the country. And we separate this into into three parts: upstream, downstream, and competitors. Since we think all these three facets will affect the relationship of the company, and we use these three numbers as factors and put them into the weight vector later. Okay, now here comes the model, and now we want to show you the overview of our model. After collecting all the data, we need to do some data pre-processing before really put it into the training model. So for financial statements, it's easier because they are already numbers. We can simply put it into vectors. But for news and the social media posts, since they are words, vocabularies, so we need to do some processing. For example, we need to use sentiment analysis to get a score that shows the negative or positive opinion toward this company. And the last one is the relationships. We use numbers to represent distances to know how related these two companies are. So after these data pre-processing steps, we will get 20 different factors, and now we are going to put them into the vector. As long as we have vectors, we can use the weight vector and put it into the model. In this step, the model we use is the XGBoost, which is a linear regression model. And after that, we can get the training model, and then we can use the training model to predict our data. And in the end, we will get a score of the risk. And so after that, investors can use this risk score to judge if they want to buy this stock of the company or not. Okay, now we are going to introduce more details of our data pre-processing. For the sentiment analysis, we use the Snow NLP, which is a Python library that focuses on Chinese. And before putting all the sentences into the Snow NLP, we need to use another tool called Jabba. This tool can help us to cut a sentence into pieces, like a phrase or words. After we have these pieces, we can give each piece a tag, and then we can use this, the word or phrase with the tag, and try to use naive-Bayes classifier to know if the sentence is positive or negative. After the training, the accuracy is about 82%. However, we found it has a downside in the sentiment analysis. That is, the model failed to resolve the semantic and polysemy problem in Chinese. Therefore, with this in mind, we turn to another sentiment analysis model. It is called a BERT. It uses sentence embedding with random forest. BERT is a pre-trained language model, and basically it used Wikidata. So it has lots of data set, and with the pre-trained model, we have the weight vector, and we also do pooling for the word embedding. And then we get the sentence embedding. The accuracy is about 92% with the random forest on. The next step of the data preprocessing is how to get the the score. So after training, we randomly choose 20 posts in each different item. For example, the product, the industry, the CEO names, etc., etc. And then we normalize it into a section of the score is between -1 to 1, and then we take the average. So here comes our sentiment scores. After getting all the numbers, all the concrete numbers, it's now for us to combine all the vectors into a vector. And here is something worth noticing is that since we think that typically the financial ratios will affect the public opinions in the next section. So here we use the sentiment scores to combine with the financial ratios from the previous section. For example, if we want to train the data in Q3, we will use the Q3 sentiment scores with the Q2 financial ratios. And there's another issue which happened during dealing with the vectors. We found that since some companies are from other countries, or they simply don't show up in the open market, so we cannot get the financial statements of these companies. So with this in mind, we use a workaround. We use the average value of each column. For example, like in the column of the total asset, we use the average value of all the companies we can find and take the average to be the number in the company that doesn't provide any financial statements. However, we also give this kind of company a penalty. It's about 1.5, since we think the idea we want to convey is if the company doesn't reveal any information about itself, we can hardly to believe it. We have less confidence about this company. That's why we want to let investors know. We want them to be more conservative. So we give the company a 1.5 penalty. So after that, it forms a vector which has 20 items inside. And now here comes the choosing of the model. In the beginning, we use LSTM. It's called the long short-term model. We try to use this to train our data. However, we found that there's a downside in our case, since we use quarter as the unit of the time step. So in 1 year, we only have 4 time steps. It is sufficient for us to do the training, because the format of the time step need to be the same. I mean, for the training data, for the testing data, and for the predicted data, they all need to the same number of the time steps. But we only have 4 time steps in a year. If we only use 1 time step, then it's a little bit weird to use LSTM. So we turn to find another model. So in the end, we use XGBoost as our model. It is a linear regression model, and it uses a distributed gradient boosting library. It trained the model by updating the gradients again and again. So now I'm going to talk more about the XGBoost model. So for the training data, we use all the vectors from the Q1 to Q3, and we use 33% of the total data as our testing data, and the rest of the 67% is our training data. The learning rate is 0.6. And after training, we got the R2 score of 0.9. The R2 score is a way for us to know how consistent the result is with the labels or with the thing we care. So if the score is 1, then it means the prediction precisely followed the label. And if it's minus, for example, it's -1, then it means that the prediction is totally on the opposite side of the label. So we got 0.9 R2 score. This means that our result is aligned to our labels. And after that, since the training model is good enough, so we use this model to predict the data. We put all the data in Q4 to do the prediction. Okay, so here comes the result, and we put all the result in our web page, and my partner will introduce more about the web page later. Thank you so much.
So I will do the demo of our user interface. So I think the IP has changed because I ran out of my GCP coupon. So I'm not sure if this IP will remain on if anyone wants to try this. So this is the interface. So you can choose a company, and there are total 352 companies in the computer industry in Taiwan. So we classified the companies into the products they produce. So, for example, companies that produce CPU, there are some Intel and some Taiwanese companies. So we first choose this one. So as you can see, here shows a risk score, and the risk score are values between 0 and 10, and it is calculated by the sentiment analysis score and the financial report ratios and the relationship between the products and other companies, and also the stock price movement. So the orange shows that the risk is like medium, and here's the sentiment analysis part. So the sentiment analysis has 8 parts. So the company news, the company PTT, and the CEO news, the CEO's PTT, and this for industry news and product news. So as mentioned before, PTT is the largest social media board in Taiwan. So with this graph, and you can clearly see that, for example, the company news of this company is mostly positive. So as you point on this, it shows how many news posts that are highly positive. So we classify the sentiment score into 6 categories. So you can easily see that for each section and how well is this company in the social media. So if we choose some other companies, so it will change. So for example, like this company, the product on the PTT is not so well, and the other is the relation graph. So I first switch to another company because this is too much. So for example, this one, and with this graph you can see the companies. This is the company, and this is the product it produces. So one thing that we want to mention is that this graph database is using RD, and because the data we crawled is all traditional Chinese, so the label and the name here is also Chinese. We only managed to change the categories into English, and all the company name is also Chinese. So you can see this company produced this laptop, and you can see all the other companies that produce the same product. So you can find it also produced by us. And the label, you can see it is produced, or this company is also producing this. So this will be the company's competitors. And the third part is the stock price. So because we are not able to get the risk score label, so we also utilize the stock price movement as a label when training our model. So the movement can also serve as an indicator of how well the company is performing. So for this stock price, you can see the stock price of each timestamp, and this also serves a rough overview of how we calculate this risk score. And the fourth part is the financial data. So there are 9 features in the financial data that we use. So these are the 9 features. So I remember for the Z5 and Z7 part, for the value being the lower, it's better. However, this bar chart is for visualization. So this bar chart is showing the ranking among the companies that we have the financial data. So the higher means it's performing better. So I believe the Z1 and Z4 is related to the company size. So as you can see, this 2 bar is very tall. So that means this company is a huge company. And for Z5, Z7, it's very low, and the Z22 is as well. I believe the Z7 is a debt to capital ratio, which means how many money does the company is borrowing right now. So this value, the lower the value is, the better it is. So as you point in the bar, it shows the actual value of this ratio, but just to visualize the height of the bar is the ranking of the ratio among all the companies. So for example, if you choose some other company like Intel, the risk score is fairly low because we don't have we miss the stock price and the financial data of this company. So we just make a rough analysis of this company. So you can see the sentiment analysis is good for Intel and also the products. However, the company in the PTT is not very well. And you can also see the Intel's relation graph. So it produced CPU and the chipset. And you can also see the competitors of Intel. And that is for our user interface demo.